Welcome back. So today we're going to be talking about systems of equations. We're only going to be really looking at linear, but recognize that we could have any two functions intersect. Actually, we may just create one on the fly at the end. So let's take a look at some simple ones. And again, you can create stuff in Desmos really easily. Especially for like systems using one positive slope, one negative, and they have to intersect at some point. So you can create as many problems as you want, and Desmos will obviously give you a solution right off the bat. But let's try and solve these out. So if I didn't have this graph to tell me what was going on, I'd have negative 3y minus 4x equals negative 11, and 3y minus 5x equals negative 61. So over time, you're going to get better at deciding which ones to do substitution on versus elimination. There's going to be some obvious ones, this one included, where you wouldn't do substitution on this one. It's too simple to add down the line because we have the same integer in front. Generally speaking, that is the rule. If you can create the same integer in front of one of the variables really easily, go ahead and do elimination. Otherwise, substitution is probably your best bet. So I'm going to add this entire function to this entire function. One of the problems I see with students is that they will only do one column or they won't apply this sign all the way through. So if I was subtracting, I have to distribute that subtraction sign to every single term, even on this side of the equation. So I'm going to add these two equations together then. Negative 3 and 3 is 0. Negative 4 and negative 5 is negative 9. And negative 11 and negative 61 is going to be negative 72. And that's fortunate for us because by dividing both sides by negative 9, we will get x equals 8. And we can check in Desmos and see that is in fact true. And I'm assuming most of you know that a solution to a system is where the two functions intersect. Know that on the praxis, it may not necessarily be visually true because it may not be a real intersection. They could have imaginary intersections. So just be aware that could happen. Don't just say, oh, there is no solution to the system because, there's some graph over here and this one will never touch it. That may not be true. So if we were then going to get our y value, we would just plug back into either function. We don't care which. Let's go ahead and do this one. Negative 3y minus 4 times 8 is 32 equals negative 11. We're going to move that negative 32 over. And that will be, 21? And we'll divide both sides by negative 3. And yes, that works out. So then on to our next one then. This was elimination method. This one, and we can kind of take a look at the graph if we want. We can see that we should probably do substitution because we already have y isolated. So y equals 2x plus 2. It wouldn't be very hard to set this one up for elimination. We'd multiply the top function by 2 and we'd be good to go. But substitution makes sense. And in fact, when you have variables by themselves like this, substitution is the same thing as elimination because we could subtract down the line and we'd eliminate the y, and then we'd have both zeros, move it over, and we'd be in the same position. So substitute this in for this y. X minus 1 equals 2x plus 2. We need to get x isolated. The larger one is over here, so we want it to be positive. Subtract x. we get x plus 2, and then we subtract both sides by 2 to get rid of this. Negative 3 equals x. And we see that that's true. To find our y value, again, we just plug into either equation. This top one looks like it'll be the easiest. Y equals negative 3 minus 1, therefore y equals negative 4. And we are correct. So here's one that's a little less obvious. We'll solve it both ways, and you can kind of decide. The answer is not very simple. I can't even tell which one it is, but we'll give this a shot. So 5y is equal to 4x minus 1, 3y minus 7x equals 2. So from my standpoint, we almost have y isolated already, so that would be what I would go for, although this problem is going to be kind of messy either way. So let's isolate y by dividing both sides by 5. 4x over 5 minus 1/5. I'm keeping them separate. You could obviously combine them since they have the same denominator. And then we're going to substitute in. So 3 times 4x over 5 minus 1/5 minus 7x equals 2. So we have to distribute this 3. That's going to be 12x over 5. That's going to be minus 3/5. And let's make these two terms over 5 over 5 as well. So to put them over 5, we multiply the numerator by 5 as well. So 7 times 5 is 35. And put this 2 over 5, 5 times 2 is 10. So now we have the same denominator for all of them. And we can start combining terms. So 12 and negative 35, that is going to be, 23? And then that'll be over 5. And we can move that negative 3 over 5 to this side, and that will become 13/5. Now we can multiply both sides by 5 and get rid of it. Actually, we could have done that earlier as well. And we get 12. Whoops, I was looking at the wrong line. We get negative 23x equals 13. X equals negative 13 over 23. So let's see if we can zoom in on this and actually see if that is true. So negative 13 over 23 is negative 565. Okay, so we found the right answer. Good. And then we could plug this back in for y as we've done in other problems. I'm not going to do that to save time. We've already seen how that's done. So let's get rid of this, and we can attempt the same problem, but we can set it up for elimination. For this next attempt, all I'm going to do is set it up. We're not going to walk all the way through it. So first of all, I want to get everything lined up. The 4x is on the wrong side of the equal sign, so we got to fix that. So we've got 5y minus 4x equals negative 1, and we have 3y minus 7x equals 2. So we don't really care which one of these we make the same integer in front, just because it's the first one I'm going to do the one in front. So to do this, we'll have to multiply this one by 3. we have to multiply this one by 5 because we need these two terms to end up being the same thing at the end. That's a prime, so we're going to multiply by each other to get there. That's going to end up being 15y minus 12x minus 3. Notice this 3 did not just go to this side, it went to every term. Same thing here, we have 15y minus 35x equals 10. And now we can do elimination. Again, when we subtract one equation from another, we subtract or we distribute this negative to everything, even on this side of the equals. 15 minus 15 is 0. Negative 12 minus 35, that's going to be 23. Yes. And negative 3 minus 10 is going to be negative 13. X equals negative 13 over 23. Again, we're not going to solve it all the way through. We're just going to stop right here. But we came to the same answer, both methods. More difficult ones, it can be kind of difficult to say which one's going to be easiest. Don't waste a whole bunch of time trying to figure that out. Just work out what's going to be most comfortable if you're not exactly sure which is the fastest and move on. So for the last thing we're going to touch on then, let's look at a word problem. So Bill goes fishing. Move this over slightly. Bill goes fishing and catches 201 pounds of catfish and bass, which he sold for $363. If Bill gets paid $2 per pound of catfish and $1.50 for each pound of bass, how many fish did he catch? All right, let's set this thing up. We've got 201 pounds, and that is equal to the number of catfish and bass, or rather the pounds that represent them. He also made $363, and he was paid $2 per pound of catfish. We already have that term defined. And he gets $1.50 per pound of bass. Again, we've already defined that value. So what we can do here then is we can use whatever method we want. Let's use substitution. It seems easy enough. C equals 201 minus B, right? I just moved B to the other side, and now I can sub in for C. 363 equals 2 times 201 minus B plus 1.5 B. And let's distribute. So that's going to be 402 minus 2B plus 1.5B. Okay, so there's going to be a negative amount of B's over here, so we're going to add them together and move them over here. And this term is going to be subtracted from this one. So let's start with subtracting this term from this one. And we're going to combine these two terms, and we're going to be left with 0.5b. Move that 0.5b to the other side. 0.5b equals 39. Therefore, multiply both sides to get b by itself, and b equals 78. If b equals 78, and both of them add together equals 201, we can just subtract 78 from 201, and we'll get that C equals 123. And we can check that work by plugging it into this one. So let's just throw that into our calculator. 123 times 2 is going to be 246. And 1.5 times 78 117, 3, 5, actually 6, 3. We're good. We check out and the problem is solved. You're going to run into these problems for sure. They kind of trip people up. You'll also see with like this will be the dollars or what would have you, but you're going to end up with a amount equals variable plus variable, and then that variable is going to be used again down here with some kind of rate or something attached to it. So just be aware that that's coming. And that should do it. Thank you.